So now we learned all about linear graph SLAM, and that's quite a bit. And it's really simple. Every time there's a constraint, initial position, motion, or measurement, we take this constraint and add something to omega and c. And what we add is the constraint itself, but it's up multiplied by a strength factor. There's nothing else but 1 over sigma, the uncertainty in motion or in measurements. And then when we're done with this adding, we simply calculate this guy. And out comes our best possible path and along with the map of all the landmarks. Isn't that something? Isn't that really cool? So let's dive in and have you program your own real robot example. This is a fairly complicated generalization of what we just saw. I'm giving you an environment where you can specify the number of landmarks that exist, the number of time steps you want the robot to run, the world size, the measurement range, that is the range at which a robot might be able to see a landmark. If it's further away than this, it just won't see it. A motion noise, a measurement noise, and a distance parameter. The distance specifies how fast the robot moves in each step. And then I'm giving you a routine which makes the data. It takes all these parameters and it outputs a data field that contains a sequence of motions and a sequence of measurements. The code comments on the exact format of what data looks like. Now I want you to program the function SLAM that inputs the data and various important parameters and that outputs my result, a sequence of estimated poses, the robot path, and estimated landmark positions. This is really challenging to program. It's based on the math I just gave you. The robot coordinates are now x and y coordinates. The measurements are differences in x and y. So you have to duplicate things for x and things for y. I myself put them all into one big matrix, but you can have them in 2 separate matrices if you so wish. You have to apply everything we learned so far, including the weights of 1 over measurement noise and 1 over motion noise. These happen to be equivalent in this case, but they might be different. Then you have to run SLAM and return back to me a result data structure. I'm also supplying you with the print result routine, so you can go in and see how the result has to look like. There's an example routine that doesn't work, that outputs all the correct formats, but it turns not to implement the estimate that I want you to estimate. You have to bring this to life and turn this into an amazing SLAM routine, so that when you run it, you get the same results that I do for the examples here, where there's an estimated path and estimated landmark positions. There's one last thing I want you to know is I assume the initial robot position is going to be the center of the world. So it's with the world size of 100, it's going to be 50-50, or here it's printed as 49.999, but this is the same as 50. So you have to put in a constraint that sets the initial robot pose to the center of the world.